Welcome back to All This Math. This is your host, Professor Parker. And for today's lesson, we're going to talk about some addition facts. And we're going to talk about how to find the sums of different numbers when they're added together. And in case you're wondering who this is on my shirt, I don't think you can see his name. Well, maybe you can now. This is a painting of a brother by the name of Walter Rodney. Walter Rodney was many things. He was a scholar. He was a history professor. He was a historian. He was a writer, wrote several books, one of which that was very important was How Europe Underdeveloped Africa. So that's a very important book that he wrote. He also wrote other books. He also was a lecturer and a speaker, and he also was a revolutionary. All right. He was actually assassinated in 1980. He was actually assassinated in 1980 in June, not too long after I was born in 1980. I was born in May in 1980. Yeah, I'm old. I was born in 1980. But definitely, if you're not familiar with Walter Rodney, please go look him up, do some research on Walter Rodney, and have some conversations about him, and ask some people some questions about him. All right, do some research online, or find some of his books, or find books that have been written about him, but also just ask some people about him. All right, now let's get into the math lesson. So we're going to talk about some addition facts. All right, you see we have 6 examples up here. The first example is 8 plus 5. Then we have 7 plus 6. Then we have 9 plus 7. Then we have 8 plus 9. Then we have 9 plus 5. We have 6 plus 8. Now, eventually, what you're going to end up doing is memorizing the sums of all of these equations. These are basically equations. 8 plus 5, that's basically an equation, right? Or a number sentence. You're going to memorize all of these. So the method that I'm about to show you is not really going to be necessary once you memorize them. But until you get to that point, these methods will be helpful. And in case you're wondering what this is behind me, these are just some number facts that you should also memorize. That'll help you with using the method that I'm about to show you, which is called number bonds. We're going to use number bonds. And number bonds are helpful with math because it enables you to visualize, what's actually happening when you're adding numbers together. Also, number bonds are good because when you end up doing chemistry and learning chemistry and studying chemistry, right, you're going to use bonds, right? You're going to look at bonds between different types of elements, different types of chemicals, and it's good to have it introduced early on with just basic addition. All right. So over here, these are some of the number facts of the pairs of numbers that add up to 10. Why? Why is that necessary? Why is that helpful? It's helpful because 10 is kind of like 0, right? You notice how we start counting after 0. Right? So after 0 comes 1, then 2, then 3, if we're on the positive side of the number line, right? So we go 1, 2, 3, 4, so on. When you get to 10, you essentially do the same thing, except those numbers are just 10 more than 1, 2, 3, 4, 5. For example, 11. 11 comes right after 10. 11 is just 10 more than 1. So the number in the tens place changes, because with 1, 2, 3, 4, 5, 6, 7, and so on, there is no number in the tens place. So we can think of that number as a 0, or that digit as a 0 in the tens place. But then when you get to like 11, 12, 13, 14, 15, there's a 1 in the tens place. You see what I'm saying? So here, 11 is just 10 more than 1. 12 is just 10 more than 2. 13 is just 10 more than 3. 14 is just 10 more than 4. 15 is just 10 more than 5, and so on, until you get to 20 and it starts over. 21 is just 20 more than 1. And at the same time, it's 10 more than 11, all right? But let's start talking about number bonds and how do we use number bonds. All right, so let's say you look at this problem. This says 8 plus 5, and you don't know off the top of your head what 8 plus 5 is. That's fine. One of the ways to figure out what 8 plus 5 is you use a number bond. So your number bond might look like this. But look, actually you do a number bond from the bigger number. You don't have to do it like this, but this is how I recommend it. You pick the bigger number. So with 8 plus 5, the bigger number is an 8. So I'm going to form a number bond from the 8. Now, the whole purpose of this is this. I want to create a number bond where I got 2 numbers, right? A number that I add to 8 that'll create a value of 10. All right? That'll create a value of 10. So I'm going to do this. actually, this is what I'm gonna do. I'm gonna do it a different way. I'm gonna break up the smaller number. I'm gonna break up the smaller number. I wanna identify the bigger number and the smaller number, and then I'm gonna break up the smaller number. I'm gonna create a number bond using the smaller number, right? Now, it's different ways I could break up 5. I could break 5 up into 4 plus 1, because 4 plus 1 is 5. I could break 5 up into 3 plus 2, because 3 plus 2 is 5. I could change the orders around. I could break it into 2 plus 3, or I could break it into 1 plus 4. I could do any of those things. But I'm gonna change it into 2 plus 3. I could do 3 plus 2, it don't matter, but in this case, I'm gonna do 2 plus 3. Now, why am I doing 2 plus 3? That question, why, is very important. When you're learning math, you should always try to think about why you're doing the steps that you're doing. Don't just try to memorize steps. Don't only memorize steps. It's important to memorize steps, but also think about why the steps make sense. And then throughout your mathematical career, always think about why, because that'll help you to better understand the math and understand why the math works. And then you'll be able to see the beauty of it. And once you see the beauty of math, then you'll really like it. And then you'll actually want to do it. And it'll be a helpful tool throughout the rest of your life. So I'm going to break 5 into 2 and 3 because 8 and 2 will give me 10. My goal is to get to 10. My goal is to get to 10 because 10 is like a friendly number. 10 is like a friendly number, or what we call a happy number, right? Think of happy numbers. Think of the Happy River in ancient Kemet, which we now today know as the Nile River, the Happy River. H-A-P-I is how our ancestors spelled it though, right? The Happy River. 10 is what we consider a happy number because it makes us happy because it makes the math easier and pretty efficient. So why I break 5 into 2 and 3? Because then I can do 8 plus 2 and get 10. And then I just got to do 10 plus 3. So if I do 8 and 2, I put the 8 and 2 together, right? Actually, I shouldn't have done that really, but 8 and 2 is going to give me 10 because this says 8 plus 2 is 10. And then I add that to that 3 that's left over. And remember, 10 is like almost is similar to 0 in the fact that it's got a 0 in a ones place. So anytime you add a number to 10, you're basically just like counting from 1. Except instead of saying 1, 2, 3, 4, 5, now I'm saying 11, 12, 13, 14, and so on. But in this case, I'm adding 3. So that's like doing 11, 12, 13. So that's why 8 plus 5 is 13. And we just added 8 plus 5 using number bonds. Now, like I said, once you memorize all your addition facts, all these methods are not going to be necessary, but they're still helpful to know. So what these methods do is they help you to understand why 8 plus 5 is 13. Also, these methods are going to be helpful when you start adding bigger numbers in your head. When you start adding like 3-digit numbers and 2-digit numbers, right? Knowing how numbers have relationships to each other. Knowing how to get to 10, how to get to 20, how to get to 30, how to get to 100, how to get to 200. These same concepts you're going to use going on and on, right? So that's why it's good to learn these concepts now. And this is only one of the ways that we can do this. It's not the only way. It's one of the ways. So you want to learn as many ways as possible. Now, let's look at number 2. Number 2 says 7 plus 6. So what I'm going to do is, like I did up here, I'm going to create a number bond with the smaller number, right? With the smaller number. 6 is smaller than 7, right? Now, I'm going to break 6 down into 3 and 3. Now, why do you think I did that? How come I didn't do 4 plus 2? Or 4 and 2? How come I didn't do 2 and 4? How come I didn't do 5 and 1? Any of those combinations add up to 6. And if you want to prove it, just count with your fingers. Don't feel bad about counting with your fingers. Count with your fingers for as long as you need to. Sometimes I still count with my fingers, just for old time's sake, right? There's nothing wrong with counting with your fingers, as long as you get the correct answer, right? So why did I use 3 and 3? Because 7 plus 3 is 10. 7 plus 3 is 10. And remember, my goal is to get to 10. My goal is to get to 10 because 10 is my happy number. And once I get to my happy number, now that makes my math easier. Because now, this 7 and this 3 is going to add up to 10. And then I add 3 to that. 10 plus 3 is just, imagine I got 10. and then I'm adding 3. So I'm adding 11, 12, 13. I got 10, and then I'm adding 11, 12, 13. That's my 3. That 3 right there. I already had 10 because I know 7 and 3 is 10. And then I add another 3, I get 13. All right? So this is a coincidence. The answer to number 1 was 13. Answer to number 2 was also 13. Now, number 3. Let's look. 9 plus 7. Go to the smaller number. 9 and 7. Smaller number is 7. I'm going to break 7 up like this. 1 and 6. Why did I break it up into 1 and 6? Because what happens when I do 9 plus 1? I get 10. And remember, we're trying to get to 10. That's the goal. Our goal is to get to 10 because 10 is our happy number, right? 10 is our happy number. We want to be happy also, right? We want to be happy, and we also want to reference the Happy River from ancient Kemet, right? That our ancestors used. That was very important in their civilization, their advanced civilization, right? Thousands of years ago. So we trying to get, basically think of it like this. We're trying to get to our ancestors, all right? It's like a Sankofa type of moment, right? With math. So 9 and 1 gives me 10. And then I got to bring the 6 down. So 10 plus 6. So again, we can kind of think of 10 as like a 0 in a sense. It's not exactly like 0, but it's in a sense it's like 0 because it has a 0 in the ones place. So now I'm going to add 6 to 10. So imagine I got 10. Then I'm going to have 11, 12, 13, 14, 15, 16. 6 fingers. I put up 5 and I put up another one, right? So I got 5 fingers on one hand, right? So that's 16. So 10 plus 6 is 16. Now, number 4. Now we kind of on a roll now. All right, we're getting the hang of this. 8 plus 9, find a smaller number. It's 8. Create a number bond with 8, right? So we break the 8 down into 7 and 1. Now, why did I do that? Remember, when we do math, we always ask why, right? When you sit in the classroom, raise your hand and ask why. If you ever don't understand why you're doing something, don't ever be the person, no matter how young you are or how old you are, that just sits in class and just copies down problems without understanding why that step makes sense. Why does that make sense? Always ask why. So 7 and 1, right? Why did I do 7 and 1? Because I know, again, 1 plus 9 or 9 plus 1, whichever direction you look at it, will give me 10. If I look at it as 1 plus 9, that's 10. And I'm trying to get to 10. 9 plus 1, still 10. Either way, that's 10. Right? Bring the 7 down. 7 plus 10. What's 7 plus 10? 7 plus 10 is the same thing as 10 plus 7. When we add numbers together, the order doesn't make a difference in the answer. We call that the commutative property. Or I should say the commutative property is the property that dictates that, right? 7 plus 10 and 10 plus 7 are going to give me the same answer. So boom, imagine I got 10, right? And then I'm going to put 7 fingers up and I'm going to see what number I end up at. That's going to be my answer. So I got 10, then I got 11, 12, 13, 14, 15, right? That's 5, 16, 17. 5 and 2 is 7. 17, I stopped at 17. 7 and 10 is 17. You notice I always draw a box around my final answer, just so to be clear, this is my final answer after I got all my work done. Now I'm doing 9 plus 5. 9 plus 5, what am I breaking that down into? I'm going to break that into 1 and 4. Why am I doing that? Because I want to put the 9 with the 1, and if I put the 9 with the 1, now I get to 10. My whole goal is to get to 10. I'm going to keep saying that over and over again so you can memorize it. Your whole goal is to get to 10 because 10 is your happy number. You're going to be happy because your math is going to be easier counting from 10 than counting from a number that's not 10, like 8 or 9 or 7 or 6 or 12 or 13 or 14. The math is going to be easier when you count from 10. So this becomes 10. Then you bring the 4 down, not the 5. It's not a 5 because look what we did. We broke the 5 down into 2 numbers because I know 1 plus 4 is 5. Just like 7 plus 1 is 8. Just like 1 plus 6 is 7. Just like 3 plus 3 is 6. Just like 2 plus 3 is 5. Those are, again, number bonds. And like I said, you're going to do this in chemistry. You're going to use bonds in chemistry too. All right. So 10 plus 4, remember, look at 10 like a 0. You got 10 right here, and then you got 11, 12, 13, 14. You stop at 14, right? So we got 14 right there. Boom. Now, 6 plus 8, last problem. We did 5 problems already. You're probably starting to get the hang of this. If you're not, if it's something you don't understand, feel free to rewind the video, run it back. All right, 6 plus 8, find the smaller number. 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 Now, granted, you don't have to find the smaller number. That's just the way I'm showing you how to do it. We could have did it by finding the bigger number. Or we could have did the smaller number. We could have started with the smaller number in some examples and then started with the bigger number in other examples. I just like to do it this way. But another beautiful thing about math is that you have options. There are always more than one way to do a problem. Just like there's more than one way to get from school to your house, or to get from the store to your house, right? Or to get from the playground to your house. There's always different ways you could walk. There's different ways you could drive. There's different ways you could ride your bike. There's always different ways. Math is the same way. So look, we got 6 and 8. I'm gonna go to the smaller number. I'm gonna break this down into a number bond, and I'm gonna do 4 and 2. Now, why do I do 4 and 2? Because if I put 8 with 2, that's gonna become 10. Look right here, 8 and 2 is 10. Or if you wanna look at it as 2 plus 8, that's still 10. Again, something you'll learn about more as you progress in your mathematical development is the commutative property. Like I mentioned before, I'm gonna say it again, the commutative property. It says that it doesn't matter what the order of the numbers is when you're doing addition. And it also applies to multiplication, but we're not talking about multiplication right now. We're talking about addition. But when you're doing addition, it doesn't matter the order of the numbers, the result is gonna be the same. So now we got 2 and 8, which is 10. Then you bring the 4 down. 4 plus 10. Just like we had up here, 10 plus 4. Now, if I got 10 and I add 4 to it, now I got 11, 12, 13, 14. Boom, final answer. So these are final answers. So what we did was we practiced figuring out addition facts using number bonds. We practiced figuring out addition facts using number bonds. That's what we did. All right. Now remember, you should memorize these facts because these are all the single digit facts that add up to 10, right? I didn't put 10 plus 0 in there because I don't think that's very helpful, all right, with what we're doing. All right. Also, create a number bond. Pick one of the numbers, create a number bond, but your goal is to get to 10. So you want to create a number bond that has 2 numbers in it, where you can take one of those numbers and give it to the other number or put it with the other number to add up to 10. 8 and 2 gives me 10. 7 and 3 gives me 10. 9 and 1 gave me 10. 1 and 9 gave me 10. 9 and 1 again gave me 10. 2 and 8, or 8 and 2, however you want to look at it, also gave me 10. So the goal is to get to 10. You want to get to 10 because 10 is similar to 0, and it makes the counting easier. So therefore, it makes the addition easier. Because all addition is just counting by the number that you're adding to. So if you're adding 4, it's like counting by 4s. If you're adding 8, it's like counting by 8s. If you're adding 2, it's like counting by 2s or skip counting. So addition is directly connected to skip counting, just like multiplication is directly connected to skip counting. We're going to get into multiplication too, right? And also, we already have a lot of videos on multiplication on the channel as well. We also have some videos on addition too, but I just wanted to put this video up because this video is a little bit different. All right, so definitely practice adding single digit numbers using number bonds. Find your addition facts using number bonds. Remember, your goal is to get to 10. You want to get to 10. All right, you got to know how to count already, but once you know how to count, you should be able to practice this. Your goal is to get to 10. Okay, so go practice. Remember, Walter Rodney, shout out to Walter Rodney, the ancestor. All right, go learn about him. He's a very important ancestor of ours, Walter Rodney. And I'll see you on the next video. Peace.